What's up, everybody? SysAdmin Sean here, finally back after a 2-week vacation and a couple extra weeks off for personal matters. But we're back. We're here to talk about SSL certs and the just full-on hell that they are. So stay tuned. Like I said, I was out for 2 weeks. I went to Japan for a little bit. Here are some pictures real quick in case you wanted to see a few. Pretty awesome. Had a great time. Wonderful time. Came back, took a week off, then got sick, had to take another week off, and now I'm back at it. If you want to see more photos from Japan, they're uploaded on the Patreon, so enjoy that if you want to. But let's talk about SSL certs. So SSL certs are a thing that you just have to deal with. You have to issue them, assign them, put them on web servers, and all sorts of other things. So what is an SSL cert? So basically, an SSL cert is a way to encrypt traffic between an origin and a destination so that they can prove they are who they say they are. So for example, let's pull up Digi Search certificate here. Let me get that window. So you can see we have a certificate from digicert.com. It generated by DigiCert. It has an issue, an expiration date, and a fingerprint. And it has a certificate hierarchy, so I know who issued the certificate and who they gave it to and why it's on this website, things of that nature. So obviously, since this is a outward-facing website, it's using a CA that's trusted globally. That will then issue the certificate and allow my computer to say, yep, I know that certificate chain. I know that root CA. I have a certificate on my side that says I can trust this certificate. So yeah, that's kind of the basics. So there's a certificate on the origin side or the web server that, says, hey, I'm a certificate. I'm in place of this to protect 2048 encryption, 4096 encryption, whatever you want to use. And then I also have a private key to plug in to say, hey, this is my certificate, verify it. It gets verified via the CA. The CA says this is a good certificate. And then my browser goes, yep, I see that certificate. I know that CA. Everything matches up, looks good. Those are the easy, nice, super simple certificates. We really like those certificates. They're not a big deal. Putting a certificate on a web server, it's easy. Windows IIS, super simple. Apache Tomcat, Nginx, they're all very easy. The problem comes with everyone else using certificates for a lot of different protected traffic or protected connections, deciding to use every possible combination of type of certificate. So there's not just your basic SSL cert. There's that, and that can come in a CRT, a .cer, a .pem. Those are some of the more common ones. And then you also have like a PKCS7 or PCKS7, 10, 14, tons of different options there, and they're usually not as easy to deal with. The basic situation is supposed to be you make a certificate assigning request, a CSR, and that generates your private key at the same time. You keep your private key. You send your CSR to a CA, whether that's your public-facing CA, like in Common or GoDaddy. Those places offer certificates. Digi Search, they send you a certificate back, or you use your Windows Certificate Authority in your domain, which is a way to do internal domain certificates that are trusted internally, but don't need to be externally facing. So a lot of places will have an internal domain, blah.com, whatever I used, sysadminsean.org. That was my internal domain. I could stand up a certificate authority for that domain that, as long as all of my machines knew about that certificate authority in some way, shape, or fashion, which is another set of certificates, any certificate that certificate authority generated would be trusted on my network. Much like a Windows Certificate Authority, machines that are bound to the domain trust the certificates built in that CA so that you don't have to spend money at GoDaddy or in Common or DigiCert to generate certificates for an internal domain from an external domain certificate authority, if that makes sense. And then you also have self-signed certificates, which are pretty much complete trash. They're good for testing to verify that you have an HTTPS configuration working, but they're not trusted. They're generated on the system or a different system that just generates certificates, and they're kind of garbage. So how do you generate a CSR? Well, luckily, there's quite a few ways to do that, and some places like DigiCert here have a lot of different ways to do that. So for instance, they have a Digi Search certificate utility that if you have an account with them, you can use. They have information on how to generate the openssl command. So let's say we wanted to make web.mine.org, whatever. And then organization me, department me, city New York, state New York, country USA. And we'll do RSA 4096 because cool. So there is the openssl command. So you would take that to a system that has openssl installed on it, run that command, boom, generate your certificates. And then you would put those certificates where they're supposed to be and everything would work. You would restart services. That's super great and easy until you get into something like VMware and vCenter. There is a certificate for the web front end for vCenter that you can replace and try to maintain and make it look really nice, but it's an internal system. So a lot of people just go, I'm not doing it. It's internal. No one can access it except such and such people. Firewall rules. It's blocked. It's fine. That doesn't work for everybody. Some people need to have everything secured like that. So you've got to go through the struggle of generating a CSR, getting a key and a certificate, make sure it's the right format certificate, then make sure you import it into the system the correct way that VMware wants you to do it. I think they've made this a lot easier in recent years, but it used to be a lot of command line and very little GUI. And there was the fat client back in the day. It's just, there's a lot of changes that have happened. And that's one of the big problems with SSL certificates for a lot of people is changes occur between certificates. So you could be doing your due diligence and creating documentation, generating your certificate for your application, whatever you need, and plugging it in. And then the certificate's good for a year. So you don't touch it for a year. You don't look at your documentation because you're like, certificate's fine. The year starts to come up. You get the notification from your CA. Hey, this certificate's getting ready to expire. You ready to renew it? You go pull up your documentation, look at your application, and you've patched things. You've made updates, and now the process is different, or it takes a different kind of certificate, or your CA has changed how you request that type of certificate, and you have to go through the entire process all over again. That is torturous, to say the least. And then, of course, you have certificates for things like encrypted traffic between servers, like Ishinga, for instance. You can have your nodes have certificates so that they can talk encrypted to each other. That can all be done internally, so you don't have to generate those things from a CA, which is nice. It's just you have to remember how to do that process and keep it up to date and make sure that those don't expire or your communication between your servers breaks. Puppet is another example. You generate certificates from your Puppet CA. You give that out to your Puppet nodes. If your Puppet CA isn't auto-renewing the certificates on your Puppet nodes, all hell breaks loose and your nodes don't talk to Puppet. Puppet can't keep your configuration management square. It's a pain in the butt. So what are some ways to get around all this pain in the butt? Luckily, there are a few options for doing automatic certificate renewals and management. IIS has a system built in with working with Windows certificate authorities to where you can create templates and generate renewing certificates, and the CA will just monitor the expiration date, update the certificate, and deliver it to your endpoint. But again, you have to have it configured absolutely correctly, and your mileage may vary. Usually your CA has to be done correctly and your endpoint configuration has to be done correctly. And I haven't been in a work environment where that's been the case. You can use Let's Encrypt, and Let's Encrypt uses a little piece of software called certbot. Certbot will automatically pull certificates from Let's Encrypt for you because they're free. They get rotated, I think, every 30 days, or you can make it less. I think you might be able to make it up to 90. I'm not 100% sure there, but that system can go out, especially for web servers. It works really well for web servers. It can go out. It can say, hey, my certificate's about to expire. Let's Encrypt, give me another one. Same stuff. Boom. And then it installs the certificate for you and you don't have to think about it. Sometimes it'll even restart the service. If it's HTTPD or something like that, it's service aware and it can restart the service to pull the new certificate. Certbot also has a feature related to the Acme protocol. So I'll show you that here. Pretty much the Acme protocol, a lot of certificate authorities have this. You generate a special account at your CA, an Acme account with a secret and things like that. And you can use certbot to pull specifically from your CA instead of just from Let's Encrypt or things like that. And that will help you download and renew your certificates. And as long as you configure whatever application you're using to look in the certbot destination, or if you configure certbot to go to the destination your application is looking for a certificate. For Linux, it's usually something like etc PKI, certs, private. Then your application will work and it will just grab the new updated certificate. Everything's happy. It's fantastic. One of the ways that is just the worst in the world, I think, is the Java keytool. Java keytool likes to store a bundle of certificates. You have to open up the certificate bundle, import new certificates, remove expired certificates. There's a lot to it that's manual. I've never seen an automated process to update Java keytool bundle certificates. If there is, put it in the comments, let me know so that I can pass that information along to as many people as possible. But that's one of the worst ones, Java keytool. Again, anything with VMware, they really like it when you use the GUI, so automation is kind of a problem, but luckily there's like VMware PowerShell modules that you can kind of work with, but I'm not sure how filled out that is anymore. I forget how much they're actually working on that versus probably wanting you to use something like Tanzu. I mean, that's kind of the overall architecture. Certificates are torturous because you only update them once a year and your documentation is never up to date enough. You should set expiration on your documentation for about every 30 to 60 days when it comes to certificates, just because of patch cycles and things like that. And again, if it's a web server, automate it. Get certbot on there, do it through Let's Encrypt, point it to your Acme account for whatever CA you use, and automate it. Get it out of there. I know a lot of people that just stand up a single proxy box just to maintain all of their SSL certificates for all of their web servers in one place. So instead of a bunch of servers running certbot talking out to the internet to get certificates updated, the proxy goes out, updates all of its certificates at the same time, and no one is the wiser because you're going through that proxy box for your traffic anyway, and then it's directing you to the pages related to whatever web server is running. That's a pretty cool way to do it. I know people that do it via load balancer, and a lot of load balancer appliances these days have certificate renewal automation built in, or at least the ability to do so via APIs and things like that. So those are some of the easier ways. The painful ways are when it's a weird specific piece of software. I'm looking at you, Oracle. I'm looking at you, Java, that uses a very specific type of certificate that rarely gets used by anything else. And you either have to generate their certificate and then convert it for some reason because your CA doesn't offer the extension you need. Or I've had a situation once where I had to put in a full chain certificate, but the chain that was given to me from the CA was backwards from what the application was expecting. So I had to copy and paste the certificate and flip the order. Instead of it going root intermediate certificate, like you should do, they were expecting certificate intermediate root. I don't even know why people would program it to be like that, but that's how it was set up. And it sucked. So that's about it for certificates. They are really important, but a big pain in everyone's side. If you can automate it, automate it. Anything you can do to automate it, automate it. Remember, and I'll put links down below for stuff like this CSR creation from Digi Search to have some information there. I'll put some links in down below for Let's Encrypt and Acme and In Common and some of these other places. Let me know what you use for your SSL certs. Do you just do Let's Encrypt for everything? If you're like a home self-hosted type hobbyist sysadmin, I assume that's probably where you go. If you work in a big company, do you use In Common, and the all-you-can-eat model for certificates, or are you paying per certificate at like GoDaddy, which I think is like what, $20 a certificate? And In Common's all-you-can-eat option is like $5,000 a year, which comes out really good for people like myself who have a tendency to screw up certificates when they request them the first time. We didn't even talk about wildcard certs. Wildcard certs add a big asterisk on the front of your domain so that it works for everything. I don't like them and I don't trust them, but sometimes you have to use them. So be aware that those exist as well. But yeah, that's about it. And thanks again to everybody who signed up for the Patreon. Big thank you to those people for helping support the channel. We're always looking for more suggestions for topics and projects. So do let me know what you want to see. And we'll see you in the next one. Thanks.